Good evening. In last lecture, we have started with the column. We have seen the assumptions. Then we have seen different graphs, that is for concrete, that is stress block parameter. Then for steel, FY250, we have definite yield point. And then we are with HYSD bars, that is FE415. And then we have seen we have elastic as well as plastic strain. Now we are with columns ahead. Now we have this PUZ. So when we will talk PUZ, so we have this is axially loaded, purely axially loaded, I can say pure axially loaded column. Pure axially loaded column. And we have value that is 0.45 FCK AC plus 0.75 FY ASC. We can write this in this fashion also, 4.45 FCK. Then we have AG, and then we have plus 0.75 FY minus 0.45 FCK into ASC. This we can use because we have always value of ASG, we have always value of ASC. So we need not require to calculate value of AC, and directly we can use by using this gross area and area of steel. This is given on page 71. Now we have, that is when the minimum eccentricity. Now we have seen this clause 25.4. So we will not go with that one. That is L by 500 plus D by or B by 30. So when the minimum eccentricity as per 25.4 does not exceed, means we have this value 0.05 times the lateral dimension. The members may be designed as, so 0.4 FCK AC plus 0.65 67 FY ASC. So this we can write it as 0.4 FCK AG in the same fashion plus 0.67 FY minus 0.4 FCK into ASC. So this value is reduced. So PUZ reduced by about 11%. By 11% to accommodate the moment developed due to minimum eccentricity. And we have this formula. So we have AC, area of concrete. So AC we have AG minus ASC. So instead of calculating this, we can have in terms of AG only. So this is formula with axial load and minimum eccentricity. Then on same page, we have this, the ratio of the volume of helical reinforcement to the volume of core shall not be less than 0.36 AG upon AC minus 1 FCK upon FY. So we can have volume of core. Now I will not go in detail of this. Volume of core divided by shall not be the ratio of volume of helical reinforcement to the volume of core. So we have actually volume of helical reinforcement, volume of helical reinforcement upon volume of core, and shall not be less than, means this value should be greater than 0.36 AG upon AC minus 1 AG upon AC minus 1 multiply by FCK, and then we have divided by FY. So whole divided by FY. And if this happened, then our PU becomes 1.05 in bracket 0.4 FCK AG plus 0.67 FY minus 0.4 FCK into ASC. Now this detail I will put another video for this detail. We will not go in detail with this. Then that will be again a lengthy one. Then this is most important. So we have this as PU-MU interaction curves. So we have PU-MU interaction curves. Interaction curves. Because the problem we have of axial plus uniaxial by two method. So we have one method that is theoretical method. Theoretical method. And second, we are using charts. Our syllabus is using chart only. Now question may be, we have on this chart, so we should know what we have in this chart. On y-axis, we have PU upon FCK and on x-axis, we have MU upon FCK square. What is D? D is not the depth. D, we have dimension bisected. Dimension bisected. So if it bisect width, then your B becomes D. If it bisect depth, then your D becomes D. Now we have value you can see on this. We have 0.1 to 1 on y-axis for PU upon FCK and for MU upon FCK 0 to 0.3. You may have asked values. So MU upon FCK square. So we have 0 to 0.3 and PU upon FCK square BD. So we have this value 0 to 1. Now these both values are unitless because value of MU is Newton millimeter, value of FCK Newton millimeter square, value of B millimeter, value of D square millimeter square. And this millimeter square cancels. So Newton millimeter gets cancelled. So we have MU upon FCK square unitless. Similarly for PU upon FCK square, Newton upon Newton per mm square per FCK, B millimeter and D millimeter. So millimeter square cancel with this, Newton cancel with this. So we have these values. These are unitless values. This is most important. So these are unitless. Now how we are going to select the chart, that is most important. First, we have to go for FY. So first selection of chart. So I will write over here, that is selection of chart. So selection of chart, what is required? So selection of chart. So first we require Fy value. So we have for three values, Fy 250, Fy 415 and Fy 500. Second we have, that is D dash by D. D dash by D. We have for D dash by D 0.05, then 0.1, sorry, 0.1, 0.15 and then 0.2. We have for these four values. So we have given here D dash by D. Then we have third, reinforcement on, we have two choices, reinforcement. So we have A on opposite side and that is equal on opposite side or on all faces. B on all faces. So we have, these are the three important points by which we are going to select the chart. Now in the chart we have these curves, these are P upon FCK. P upon FCK. What is P? So we have P percentage reinforcement. Percentage reinforcement. And FCK we have characteristic strength of concrete Newton per mm square. So these values are given of FYS. So we are not interested FST, but we are not interested with this. So we are being with this value. Maximum value you can see for P by FCK is 0. P by FCK maximum value 0.26. So you can see it start from 0, 0.2, 0.4 values given above the curve. 6, 0.8, 0.1, 0.12, 0.14, 0.16, 0.18, 0.2, 0.24, 0.22, 0.24, and 0.26. So knowing value of Pu upon FCK BD, we will plot horizontal, and knowing mu upon FCK BD vertical. So actually the values which intersect gives a P by FCK. Now you can see we have this value that is between 0.12 and 0.14 around center. So we will take P by FCK 0.13 and multiplied by FCK, you will get value of P. So P is 0.13 into FCK. Likewise, we have to use chart. And then that is for singly, axially loaded plus uniaxial. Now for biaxial, we have given this formula MUX upon MUX1 upon into alpha n plus MUY upon MUY1 alpha n less than or equal to 1. MUX and MUY, these are given values. Given values or by external loads. And we have to check these values with E, we have to consider from L unsupported by 500 plus B or D by 30 and minimum should be 20. E minimum, we have 20 mm. And then from this, we have to find again MUX and MUY. And maximum of the two we have to consider. One that is given in the problem and second by using this value of E. You can see the problem we have taken in the class. And that value should be less than or equal to 1. If less than or equal to 1, then we have that column that is safe. Now alpha n we have to find. You can see this. And for alpha n, we have given this one. Pu upon Pu z 0.2 to 0.8. The value of alpha n varies linearly from 1 to 2. So if I will plot this, then we have this will be alpha n. So we have this value 1, we have this value 2. So if we will do this, and then we have Pu upon Puz on this, Pu again this is unitless, and we have this will be 0.2, 0.4, 0.6, and then 0.8. And in this, our value that is increases from 1 to 2 linearly. So we have this value and here we have 2 value. So if we will connect this means below 0.2 we have value 1 and above 0.8 we have value 2. So alpha n equal to 1 for Pu upon Puz less than 0.2 and alpha n equal to 2 for Pu upon Puz greater than 0.8. And in between, we have to interpolate the value of alpha n. So this Puz that we know already, we have seen Pu that will be given. And by this, we are in position to check this value. MUX1 and MUY1 maximum uniaxial moment capacity we are going to calculate from chart. So this is capacity of this section and these are the external values. And then from this we have to find this member subjected to combined axial load and biaxial bending. So likewise we have to go for column that is purely axial, then axial with minimum eccentricity with axial load plus uniaxial moment and axial load with biaxial moment. Now we will stop here only. Thank you.